This video will demonstrate how to perform a titration. The first step is to standardize the titrant using the primary standard potassium acid phthalate. Transfer the primary standard into the Erlenmeyer flask quantitatively by first pouring the acid in and then rinsing the whey boat into the Erlenmeyer flask. Rinsing the whey boat ensures that all the primary standard is transferred. Fill the Erlenmeyer flask with approximately 25 milliliters of water. Swirl the flask to dissolve the primary standard. It will take a little bit of time to get the standard to dissolve completely. After the primary standard is completely dissolved, add 2 drops of the phenolphthalein indicator. Transfer the Erlenmeyer flask onto the stir plate. Lower the burette tip so that the tip is inside the Erlenmeyer flask, and add the stir bar. Turn stirring on to a low setting. Record in your notebook the initial volume on the burette. Use a burette card to make it easier to read the volume. Burette cards work best if they're positioned so that the black line is below the meniscus, allowing the black to reflect up onto the meniscus. Remember to record volume from a burette to 2 decimal places, so the volume here is approximately 0.93 milliliters. The first titration you'll be performing is a qualitative titration. The purpose of the qualitative titration is to quickly determine how much titrant you will need to add to reach the endpoint of the titration. A qualitative titration is not meant to be accurate, so you can proceed very quickly in the titration. Begin the titration by opening the stopcock fully, allowing the titrant to flow quickly into the Erlenmeyer flask. You can keep the stopcock fully open throughout this entire qualitative titration. Turn off the stopcock when the solution turns pink, indicating that the endpoint of the titration has been reached. Record the final burette volume. Here the final volume is approximately 14.34 milliliters. Determine the volume of titrant added by subtracting the initial burette reading from the final burette reading. Here the volume of titrant added is 13.39 milliliters. Now that you know approximately how much titrant you will need to reach your endpoint, you're ready to perform your quantitative titration. Since it took just over 13 milliliters to reach the endpoint in the qualitative titration, I can plan to titrate quickly for about the first 11 milliliters, and then at that point I will slow down and proceed drop-wise until I reach the endpoint of the titration. Before you begin titrating, take the initial burette reading, which here is 21.83 milliliters, and I'm expecting a final burette volume of around 35 milliliters, which I determined by adding the volume of titrant that we used in the qualitative titration of 13.39 milliliters to our initial burette reading of 21.83 milliliters. Now that I know what to expect, I can titrate very quickly until a volume of about 33 milliliters on the burette. Here I am demonstrating the proper technique for titrating, which involves controlling the stopcock with your left hand, putting your thumb in front of the stopcock and your other fingers behind it. This hand position gives you the best control over the burette. You can see I've stopped the titration at a volume of approximately 33 milliliters. And from this point, I'll proceed very slowly, adding the titrant dropwise until I reach the endpoint of the titration. As soon as the solution turns a pale pink that persists for at least 30 seconds, the titration is complete. The last thing to be done is to record the final burette volume, which here is approximately 34.05 milliliters. In lab, you'll perform 1 qualitative trial and then 3 quantitative trials with your primary standard in order to standardize the sodium hydroxide concentration. This titration is the one that was just demonstrated in this video. After standardizing the sodium hydroxide, you will then perform 1 qualitative titration and 3 quantitative titrations to determine the concentration of a solution of hydrochloric acid. This titration can be performed in the same manner as was just demonstrated in the video for standardizing the sodium hydroxide.